Okay. In the last few lessons, we've been simplifying rational expressions, multiplying, dividing, adding, and subtracting. One of the things I want to look at is what's happening when we simplify those rational expressions. In other words, when we've divided something out from both the numerator and denominator. So let's take a function and let's really analyze everything we can about it. Okay, so let's take this function here. The first thing I want to do is factor both the numerator and denominator. So the numerator is x squared minus 4. Well, that one's easy. That's x plus 2 and x minus 2. The denominator is x squared plus 5x plus 6. That's going to factor into x and x. What multiplies to be 6 but adds to be 5, that's going to be plus 2 and plus 3. So the parts that are going to divide out are those x plus 2's. Now we mentioned that that means negative 2 is still a bad number, but let's see what actually happens. So we end up with this function x minus 2 over x plus 3. And let's try to recall everything we know about that. Well, some of the things we've talked about already were our vertical asymptotes. Our vertical asymptotes occur whenever the denominator is 0. So the vertical asymptote occurs when the denominator is 0. So it occurs at x plus 3 equals 0, or when x is negative 3. So it is that line, x equals negative 3. Another important thing that we learned about before were our x-intercepts. Our x-intercepts occur when y is 0. Now when we looked at that, remember that's when x minus 2 over x plus 3 equals 0. When we cross multiply, that denominator is always going to multiply by 0 and go away. So you just end up really looking at when your numerator is 0. And that's going to be when x is 2. Our y-intercept occurs when x is 0. So that one's super easy. We're just going to plug in zeros for all our x's. And we get negative 2/3. There was a last thing we talked about, and that was a horizontal asymptote. Now, the horizontal asymptote, if your degrees are the same, you find that by really just dividing those leading coefficients. So if we look at those leading terms and we divide the leading coefficients, that's a 1 and that's a 1, so 1 divided by 1 is going to give me a 1. Now I want to see what happens on the graph when x is negative 2, because we know that x can't be negative 2 and it can't be negative 3. Now negative 3 was a vertical asymptote, correct? What is that happening at that negative 2? It's in the numerator, but it's not an x-intercept. It's not a vertical asymptote. If we plugged in negative 2 into the original function, we actually get 0 over 0. And that's a very strange case. So what I'm going to do is actually plug in the original function into my calculator. So first it helps to have a calculator. And we are going to plug in the original function in. And notice I put the numerator and the denominator in parentheses. And I'm going to look at the graph. Notice that we have this horizontal asymptote when y is 1. Notice the vertical asymptote at x equals -3, -1, -2, -3. If I drew an imaginary line, it would separate those two branches. My x-intercept is supposed to be at 2. Looks like it's right there. And if I look at the table, I can double check that. When x is 2, y is 0. My y-intercept is supposed to be -2/3. When x is 0, y is -0.66667, repeating, which definitely is that y-intercept. So everything checks out, but what's going to happen when x is -2? Well, the graph doesn't look like it, looks like it's actually there. Let's hit the trace button and kind of explore. What happens when we get to -2? Well, it looks like we're getting there. I'm right close to it. If you're on the trace feature, you can actually plug in an x value. It says when x is -2, there is no y value whatsoever. What actually happens on the graph is you get, for lack of a better word, a hole. There is a hole when x is -2. So when those factors divide out, we get a hole in our graph. Now let's see if we can graph everything else. So, here we go. Y equals 1 was a horizontal asymptote. X equals -3, 1, 2, 3, is my vertical asymptote. X equals 2 is my x-intercept. And -2/3 is my y-intercept. So I know my graph has to go through those 2 points. Remember, we're bounded by that graph. Can't go past it. I'm bounded by those asymptotes. So my graph is coming in, goes through here, and normally it would just keep turning and go down. We have a hole where x is -2. So down here, I'm literally going to put a hole. There is a break in the graph. The other branch is going to go up here. And that's what happens when you have that simplified part. We're just going to have a hole in that spot. So let's see if we can find some more of them. Okay, so the first thing we need to do is factor both the numerator and the denominator. So notice in that numerator there's only two terms. So one thing you want to look at is what do they have in common. Well, first see if it's the difference of two squares. If it's not, then what do they have in common? Well, that would be an x. So it'd be x times x minus 1. Over x and x multiplies to be a negative 4 but adds to be a 3, so it's going to be a positive 4 and a negative 1. So notice these are going to divide out. Before I go too far, our domain is still that x cannot equal negative 4, and it still can't equal 1, but there's a difference in those two values. Negative 4 is going to be a bad number because it's going to be our vertical asymptote on the graph. 1 is going to be a bad number because it's going to be a hole. So let's look at this simplified function. We have x over x plus 4. So let's just list out all the key features. That vertical asymptote is going to happen when the denominator is 0. So that's going to be at negative 4. Notice how it matches. We're going to have a hole when x is 1. Our horizontal asymptote, these are the same degree, so we divide our leading coefficients. It's going to happen when y is 1. Our x-intercept occurs when our y equals 0. Now that is happening when our numerator is 0, so that is at 0. Which means our y-intercept, whoops, that's right, x-intercept, x is 0, y-intercept is going to be y is 0. I'm having a brain damage moment. So when we make a quick sketch of that, one, two, three, four. Horizontal asymptotes at 1, going through the origin. But when x is 1, we're going to have a hole, a break in that graph. Everything else goes like normal. Notice some things we can also talk about. This one is shifted which way? Well, it's shifted left, how many? 4. Up, 1. You'll still need to remember how the graph gets shifted for part of your assessments. And we can double check in the calculator if we want. Okay, the next one is going to be a trickier one. Three minus x over 9 minus x squared. Okay, so that gives me 3 minus x over, well, that's going to have to be 3 plus x, and a 3 minus x. Those are going to divide out. Be careful here. That leaves you with a 1 over 3 plus x, or I can call that as x plus 3. These divide out. Notice my domain is still that x cannot be negative 3 or 3. Negative 3 is a bad number because that is the vertical asymptote. That makes the denominator 0. 3 is a bad number because that's where the whole is. Now this one's also going to be an interesting graph because since there is no variable in the numerator, I am not going to have an x-intercept. What about my horizontal asymptote? Remember we said that it had to have the same degree. So we need to explore this one a little bit in the calculator. So I'm going to go back to my original function, and that was 3 minus x divided by 9 minus x squared. And let's take a look at the graph. Well, that is interesting. I see my vertical asymptote, but where is my horizontal this time? It sure looks like it's at the x-axis, and it actually is. The horizontal axis at asymptote is going to be at y equals 0 when the numerator has a smaller degree. And think about it kind of as dividing. You know, before, if you had, that's too many e's for degree. If this had been a 3x squared divided by x squared, you'd get a 3. So you can divide your coefficients. 1 divided by 1 is a 1. If I try to divide an x by an x squared, I can't do it. It goes into it 0 times. So 0 is going to be that horizontal asymptote. So let's see if we can pinpoint where our horizontal asymptote is going to be in a few other problems. Actually, let's see how many key features we can do. Factor if you can. It's going to be x plus 2. Then x plus 1 times x minus 1. Ooh, this one's interesting. Notice that the numerator has a smaller degree. I can't divide x by x squared. So I end up with a horizontal asymptote at y equals 0. But notice this. I have two things that are still in the denominator. Can a graph actually have two vertical asymptotes? Let's find out. If I go back and put the original in, 2 plus x divided by x squared minus 1. Oh, nifty. Notice that I have two vertical asymptotes. There's a part in the bottom section, and there's two of those branches going around there. So the horizontal asymptote I see is the x-axis. Vertical asymptote, I actually have two of them this time, at -1 and at 1. This time I didn't have any holes. X-intercept. X-intercept was found by really just looking at the numerator. So what would make the numerator be 0? Well, if I look at the numerator, x plus 2, that's going to be a -2. It's actually the point -2, 0. Y-intercept is found when x is 0. So what happens if I plug in 0 for my x's in my original? Well, I'd have 2 over -1. Well, that's still -2. That's pretty nifty. Okay, so at x equals -1, I have a vertical asymptote. X equals 1, I have a vertical asymptote. I'm going to be hovering around that x axis because my horizontal asymptote is there. There are no holes. My x-intercept is at -2. My y-intercept is at -2. Now, remember, we looked at the calculator. It does something like this. Notice it did kind of cross there. I wonder what happens on the other side of it, because I said it was a horizontal asymptote. So let's look at the table. When x is -2, my y value is 0. It is crossing it a little bit. And then it's going negative. That is super interesting. And that's really happening because we have this weird situation where the numerator and the denominator is larger. So it's actually hugging that x-axis. It's getting super, super close. So when we're talking about end behavior, the left and the right side of the graph are just going to keep hugging and hugging and hugging that x-axis. So yeah, I know it crossed a little bit in the middle, but when we're really talking about the horizontal asymptote, we're talking about our end behavior more than anything else. All right, so let's do one last one. Let's see if we can talk about everything that we can in it. Well, maybe not the last one. We'll get to see how many we get. X squared plus 5x minus 14. And in the denominator, we have x squared minus 4. And we're going to talk about anything and everything we can. First thing we want to do, factor. Multiplies to be -14 and adds to be a 5. That would be a 7 and a -2. In my denominator, x squared minus 4 is going to factor into x plus 2 and an x minus 2. Notice those are going to divide out. What does that mean we have at x equals 2? It means we have a hole. Remember, our domain are the restrictions on our x values. They are still -2 and 2, but those two mean different things. The -2 is going to represent our vertical asymptote. The 2 is actually a hole in the graph. Now our horizontal asymptote, we look at those leading terms. X squared divided by x squared. That's going to give me a 1. My x-intercept, I can actually find that one by looking at that numerator. What's going to make x plus 7 equal 0? That's going to be -7. My y-intercept is found when I let x be 0. So I'm going to have 7 over 2, which should be 3.5. And those are all our key features. So to sketch it, -7 is my x-intercept. 4, 5, 6, 7. At x equals -2, I have a vertical asymptote. At x equals 1, I have a horizontal asymptote. When y is 3.5, I have my y-intercept. And I have a hole when x is 2. Okay, so let's think about how this graph is going to go. Since I have to go through this point, I know I have one branch over here. It's got to go through this point. It's got to get really close to that horizontal asymptote, especially on the edges. Here, I've got to go through that point. But when I get to when x is 2, I've got a hole. So I need to put a hole in my graph. And then I can keep going. Last example. This one will help so much with your embedded assessment. It has f of x equals 2 over x minus 2 minus 3 over x squared minus 2x. So we're actually going to have to subtract before we can analyze this one. So x squared minus 2x. Well, that's really x times x minus 2. Right? X times x minus 2. So this one needs an x. So I need to multiply the numerator and denominator by the x. So that's going to give me a 2x minus 3 over x times x minus 2. So we end up with two vertical asymptotes, huh? And that doesn't factor anymore. So, okay, so vertical asymptotes, we get one at 0 and another one at 2. Nothing divided out, so no holes. What about the horizontal asymptote? Our numerator is a degree of just 2x. That's a degree of 1. The denominator is technically x squared. It's an x times an x. So the numerator is a smaller degree. I can't divide x by an x squared, so I get a horizontal asymptote at 0. 2x minus 3 is 0, helps with our x-intercept. So if we look at that numerator, if we set it equal to 0, I'll have 3 halves. So that'd be 3 halves comma 0. Y-intercept, oh, wait, x can't be 0, so there is no y-intercept. Now, it is okay to touch that horizontal asymptote somewhere in the middle, but not on the edges. So let's see what we have here. We're going to have one vertical asymptote at 0. We're going to have another one at 2. So we're going to have two parts of our graph there. 1.5 is my x-intercept. So this one might be helpful to look at in the graph and see what this crazy thing is doing. So, 2x minus 3 divided by, and notice what I'm going to do here. I'm going to actually put in the x squared minus 2x, because I know that's what that is multiplied together. Let's see what the graph does. Okay, so it's hugging the horizontal and going down. And then we got a little bit of a, almost a cubic there in the middle. So notice it did cross that horizontal asymptote in the middle, but not on the edges.